Alright class, in this lesson we're going to take a look at section 6.2 where we're talking about integers. And we've already taken a look at some of the number sets, and here we're going to add to it. So the first three number sets we've talked about in natural numbers, so that's 1, 2, 3, 4, 5. They're basically whole numbers but not including 0. 0 includes all the whole numbers, which is 0, 1, 2, 3, 4, 5. So the difference between natural and whole is that 0 is just not natural. We usually don't start counting at 0, but 1 is natural. So integers is what we're adding to this lesson today, which is negative to positive whole numbers. Basically, it's all the whole numbers, but then you've got all the negatives as well. And so what we're going to deal with is adding and subtracting integers. And if you're ready to click stop because you're like, I know how to add and subtract, well, my hope is that, yeah, on top of that, even if you didn't know, you know how to use a calculator well. But what we're going to try to do here is conceptualize it and look at it from a different lesson or a different point of view. And so the key here is that if we understand why a rule works, it will help remember the rule better because you know what it's telling you to do. So here we're going to be looking at adding and subtracting integers on a number line, which is going to help us with our concepts of subtracting and getting negative results. So here what we're going to be looking at is something like adding 3 and 5, which gives us 8, of course. But the reason why is because we're starting from 0 on a number line. We're going up 3 places in increments of 3, and then we're adding from there another 5 places. And if you're just counting it out on a number line, you would end on 8. Whatever you end on, that is the sum of those numbers. So down here, we're going to add 9 and negative 12. Well, if I add 9, I would add the 9 and count 9 spaces. And then if I'm adding negative 12, that means I just count backwards 12 spaces. And if I count back 12 spaces, I land on negative 3, and 12 minus 3 is 9, or sorry, 12 minus 9 is 3, and so we know that if we actually did the subtraction, we would get negative 3, but this is visualizing it, seeing why it actually works that way. So we're going to try to do this on a number line here, and what we're going to be getting, let me just go ahead and just give myself my marker here, is take a look at 4. So if I go up to 4 here, count 4 spaces, and then add from there 6 spaces. So I get from 4, 1, 2, 3, 4, 5, 6 spaces gets me up to 10. And that is why 4 plus 6 is 10. Oops. And then here, if I do positive 8, so basically if I go up 8 spaces, erase this. So if I go up 8 spaces, it gets me right here. So this is at 8. And then if it says minus 13, I want to go back 13 spaces. So I go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces. If I counted that properly, we should be back 13 spaces. And let's see. Yes, negative 5 is the result. So 8 minus 13 is 5. And as you could also type it in, by the way, when you're adding negative numbers or subtracting negative numbers on your calculator, you do want to use the parentheses. That is very helpful. And then here, so negative 23 and positive 35, if I was to add these on the number line, so here, when you have a negative number first, it means you need to go back to 23, which is going to be right here. So if I go back to 23, it says add 35. So if I add in groups of 10, it'll probably go a little bit quicker. But so here's negative 23. So if I go here, this is adding 10. If I add here again to 3, I added 20. And if I go over here to 7, this would give me my extra 10, so this is 10, this is another 10, this is another 10, so I've added 30, and I just got to go 5 more. So I go 5 more right here, and my result is 12. And as I said before, if you actually do this on your calculator and do negative 23 plus 35, you'll get 12. But the point is that we're visualizing why you're actually getting it. It's because you're starting at negative 23, and you're adding 35 to it. So in other words, coming back this direction, a total distance of 35. So my little increments are pretty small, but I mean, if you actually had a nice number line and you were working, counting out left and right, you would get these same results. But you can also get them on a calculator, and you're in front of the computer, so you use your calculator, it's just fine. So here we've got to get our definition of opposites or additive inverses, and what it's saying is two numbers are additive inverses if you actually add them and the result is 0. So here we've got -8 and +8 are opposites because if you add them you get 0, and you probably already knew that. But here, taking a look, is if you have things that are equidistant from 0, like -8 and +8, they're opposites. -13 and +13, if you add them, they would give you 0. They are equidistant left and right on the number line from 0. And the interesting thing is that 0 is its own opposite because -0 a negative times 0 is still 0. So it's its own opposite. Okay? So here we've got if A and B are integers, then A minus B is equal to A plus a negative. Now you may have heard this, is that rather than subtracting, in algebra you add a negative amount, and my frustration was, isn't this always the same thing? That's the way I always looked at it. Isn't just 3 minus 8 the same thing as adding a negative? Of course it's the same. If you take your calculator and do 3 minus 8, you're going to get -5. If you take 3 and you add -8 to it, you're going to get -5. The reason why we're looking at it as add a negative is because it makes more sense on a number line. If you go to 3 right here, and then you add a -8, so in other words, I added 3, then I'm adding a -8, I'm going to land over here on -5. So this is adding a -8. So the reason why we're talking about it this way is so that we can understand how to add it. Basically you're adding a +3 and a -8, and the overall result, if you blend it together, is -5. The other reason we talk about adding a negative is because whenever we have a negative minus a negative, you're really adding a positive. And let's talk about why this works here on the number line. Maybe you've seen this before and you've always heard, oh, you just change, or you add a positive whenever you have -6 minus -19. Well, this might be the first time that you've ever visualized why that works. The reason why it works is because you start at 0 and you go -6. So I just got down here to -6. Okay? And what it's saying to do is you're subtracting off of this negative amount a -19. So we're taking -19 away from that. In other words, we need to, I was just realizing that saying taking -19 off -6 is a little bit more difficult. Let's change it to -6 minus -3. Let's do that instead. It'll probably make it a little more clear. So basically, I've got -6 here, the quantity, and I want to subtract off of there -3. Well, here's the amount of -3, and I want to cut it off of there, and your leftover amount is -3. So in other words, I'm cutting this amount off, and it's going to go this way. It's bringing my number back to -3. So I've got 0, and I'm cutting off a -3 from here, cutting this distance off, basically bringing this back. I'm cutting off a negative amount at the end. So let me draw that a little more clearly. So again, I'm changing this to -6 minus -3 first, and I'll go back to the other one. So -6 is over here, and I want to cut off 3 spaces from it. I want to cut off 3 negatives from it, and that result at -3 is where I end up at. So that's kind of what I'm doing here. Is let me erase with the -6 to the 19. So I got -6 here, and I want to cut off -19 spaces. So that's cutting off. I'm only -6, and so it's like someone saying, well, I'm going to cancel out -$19 that you owed me. And you're like, well, I only owed you 6. Well, yeah, I'm still cutting that off. So that means you're coming back all the way. So I got all the way back to your +13. So this is cutting off -19 spaces. It's like saying, all right, well, you're at -6, and I'm canceling out all that debt all the way back to basically you have a positive balance of 13. So it's cutting off -19 of debt that you didn't even have in the first place. You only owed $6, and someone's saying, well, I'm gonna take off $19 of debt. Well, I only owed 6. Well, that means I have a positive balance of 13. And that's why you have been told or the years to just change. And whenever you have minus a negative, you add a positive. Just like that, change, okay? So, let's take a look. Oops, some more rules. So, two negatives make a positive. We just kind of discussed that a little bit, and it's not that two negatives makes a positive, it's that when you're subtracting a negative, you add a positive. So, two negatives, when you add these two negatives, it doesn't make a positive, but when we have two negatives, it's a negative multiplied by a negative that makes a positive. So whenever you have a negative times a negative, that gives you a positive. So here's some rules with multiplication. So we've got positive times a positive gives us a positive. Here we have a positive times a negative gives us a negative. Negative times a positive gives us a negative. And then a negative times a negative gives us a positive. For what these are the rules. You've probably heard the rules before. Here's the actual overall rules, but here's why they're working. So if I have a positive times a positive saying, all right, for the positive next 3 days, I'm getting $5. Well, that means I'm going to have a positive dollar amount. Or if I look at it this way, for the next 3 days, I'm going to spend $5. So how would that work? Well, in all, I end up spending, I lose $15. So I want to show that I lost with the negative sign. So I add a positive 3 days, and I lost $5 each day, so 3 times 5 is, of course, 15, but it's a negative because I'm losing. Okay, so down here, the situation is for the past 3 days, so that's going back in time. I got $5, so that's looking back. So in other words, 3 days ago, how much money did you have? So for the last 3 days, I got $5, so if I look back in time, I wouldn't have had the $15 I do now, so it's a negative amount 3 days ago of how much money I had compared to now. And then, I know that one's a little awkward, but for the past 3 days I spent $5. So going back in time, I would have had a positive 15 compared to what I have now. So that this is saying last 3 days I spent $5, and so in all I spent 15. But this is talking about the 15 is saying I had $15 more 3 days ago. So in other words, 3 days back in time, I had $3 more. So hopefully that helps a little bit. These are the rules. They always work. Whenever I have the same sign, the multiplication is positive. Whether they're both negative or both positive, you multiply, the answer is positive. If they're opposite signs, one positive, one negative, then the answer is going to be negative. Okay, so practice with these rules. If I'm multiplying 4 times negative 6, of course, the answer here, we get 24. Negative times the negative. I like to even just write them next to each other so that I can see I'm making the negative times the negative positive. The answer is positive 24. Okay, so 8 times 7. Okay, now here the negative times the positive is going to give me a negative result, because anytime you have opposite signs, you get a negative. And I always want to worry about my sign first before I get too excited and do the multiplication. But the answer here is going to be negative 56. Oops, 56, not 55. Okay, so here's the situation. Assume that stock for iTech, an international technology company, has been losing value $3 a day for each of the last 8 days. How much more was the stock worth 8 days ago? And so here what we're saying is that $3 a day for 8 days. So the numbers that you're multiplying are 3 times 8, but we're talking about each day we've been losing. So it's been losing $3 a day, and then we're talking about past time, so the last 8 days. So what we wanted to say here is 3 times 8, and then our answer is going to be positive 24, because we're going back in time. We're saying how much more was it worth 8 days ago, and you wouldn't think a negative amount if you're talking about more, so our answer's got to be positive, because again, lost each day and then past days gives us the negative. So negative gives us reference to time and quantity. Okay, so that's explaining. If you want to pause and read, then that's saying what I just said. So here's a new situation. If the stock continues to lose its value at $3 a day, how much less will the stock be worth in 4 days? So again, here we're losing, so it's a negative quantity, and then we're going forward in time. So this is a positive 4, and so that means we're going to get a 12 that is negative, because we have negative times a positive here, because we're going forward in time. So our amount is negative 12. In other words, from now, I'm going to be $12 down if my stock continues in that direction, if I'm following that trend. Here you can read what I just said. Okay, so then we've got dividing. Division rules are the same as our multiplication rules. If I have same signs, the answer is positive. If I have opposite signs, the answer is going to be negative. So positive divided by positive is going to be positive. So here we're going to get positive 3. Here we have opposite signs, so it's going to be negative 2. Here we have opposite signs, so it's going to be negative 5. Here we have same signs, so it's going to be positive 4. You don't need to put the plus sign, but the answer is 4. Okay? So same exact sign, rules as multiplication. Now I just want to throw a PEMDAS pyramid at you. Maybe you've heard of PEMDAS before. Maybe somebody has told you the acronym. Please excuse my dear Aunt Sally. To remember order of operations. The one thing I want to draw out today that might be new for you, or maybe you just didn't catch it, is that it's not always having to be in this order. So in other words, if I have 6, whoops, it's going to show up anyway, but if I had 6 divided by 3 times 2, well, let's times it by a bigger number, times 7, let's times 7, that's for sure better. My answer would be wrong if I actually followed the letters first. If I actually do multiplication before division in this problem, I would get a wrong answer. Because we forget that PEMDAS isn't always do parentheses, then exponents, then multiplication, then division. It's actually a tiered pyramid structure. And so we're going to talk about that in a second. So we'll remember the problem 6 divided by 3 times 7, and worked out using PEMDAS. So first thing is parentheses, then exponents. That's always the same order. And then multiplication, division is actually left to right. It's not multiplication, then division. It's multiplication, division, whichever one comes first. And then addition and subtraction happens left to right also. So the way that I had that problem, 6 divided by 3 times 7 has to be 6 divided by 3 first. So you have to do this and get 2, then times that by 7 to get 14. You would get a wrong answer if you said 6 divided by 21. If you did that part first, you would get a wrong answer, and it would be an ugly answer. Here we want the actual 14. This is done correctly over here on the left. Okay, so just a quick little rundown on PEMDAS. This is the order for all problems in all of math. And so the reason I show you those is just because here you are going to have some problems where you have to do parentheses first or multiplication first. Whenever you have parentheses next to each other, it means multiplication. You'll see this dot. The dot replaced the x for multiplication for algebra because x is a variable. And so here we want to multiply. Negative times negative is positive 6, plus positive times a negative is going to give us a negative 32. So we're adding a negative, oops, that was supposed to be a negative sign, negative 32. So then we just have to do 6 plus our negative 32, or 32 minus 6, if you will, and get a negative 26. And then here we do a very similar problem. So we've got 8 times negative 2. It's going to give us negative 16. And then here we have negative times negative is positive 15. And then negative 16, positive 15 is going to give us a negative 1 result, because we have a negative amount here and a smaller positive amount. And we can do it on our calculator, or you can just, however you want to do that. Calculator will work fine. You've got it sitting there in front of you. There we go. Determine if the statement is true or false. Another type of problem that you're going to see in your homework set. If it's false, provide a counterexample. It says the product of 2 negative integers is a positive integer. So the product of 2 negative integers would look like negative 2 times negative 4. And so the result is a positive integer. And our rule says that if I multiply the same signs, regardless of what they are, you're going to get a positive. So this one is a true statement. So we've got the product of 2 whole numbers is a positive integer. A whole number was defined as being 0 or more, 1, 2, etc. So we multiply two of them together like, oh, I don't know, 0 times 4. Uh-oh, I just got 0. 0 is not positive, it's not negative, it's actually neutral. So this one is actually false, and here's my counterexample. Okay, so you got to work back on what our definitions say for each of these problems. So it's going to be a little bit tricky in your homework, but just there's an example of a true one, here's an example of a false one, and the counterexample I just gave you was 0 times 4. Working with whole numbers works outside their definition. So good luck on your lesson. If you have any questions, ask me through the Ask My Instructor feature of the web.